Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Welcome to Science in the Real World, another episode where we get a chance to show you a little bit how math incorporates into science, incorporates in the real world. We're here live today at the Buena Vista Museum of Natural History and Science, a place that I drive by often and don't even know what goes on here. So I'm really curious to see what's going on. So we brought along Dave Hanley. He is the board vice president and secretary, and we're so glad to have you, Mr. Hanley.
It's my pleasure. It's my pleasure.
Really glad you could be here. So when I drive by this place on Chester Avenue, right, I see the signs that says museum, but I've never been in here. So why is this museum here, and give us just a real brief overview of what goes on here.
We originally started out, we were attached to COM.
Oh, okay.
And it was based originally on the Miocene fossil bed. Kern County has the largest Miocene fossil bed in the world. 126 square miles of fossil bed up in the foothills, both sides of the Kern River. That's why your kids ended up finding shark's teeth.
That's right, we were talking about that,
So I got involved with this partly because Dad was working with the reptiles out there, but I saw the natural history, and I love natural history. So we started with the natural history, but as I've come on the board in the last 20 years, we've had a huge interest in all of the sciences. Kern County has more science than any other county in the continental United States.
It's an amazing place to live, isn't it?
Absolutely. We're blessed to really be here. We have the largest Miocene fossil bed. We've got the largest agricultural development. We've got more endangered species than any other county in the continental United States. We've got a spaceport out in Mojave. We have the Naval Weapons Center out there on the east side. Yeah. We have Edwards Air Force Base, where part of the time they developed the shuttle and the astronauts and the moon landers and stuff like that out there. We have all the way over, we have petrology, and the petrology's here because we had the Miocene fossil bed. That's where the oil got made. Yeah. And so we have the seismology along with the faults, where we have the Pacific plate dipping into the North American plate, and that subduction is what caused the tilt blocking, which provided us with the cracks in the earth, which made for the gold and the silver to become placer and became the foundation for Kern County, back with Avila being the county capital. So,
and it gives Ridgecrest something a little bit shaken up over there too, right?
Well, absolutely. That's how the volcanoes got out there. So we've got the obsidian, and so we just have more science. So we decided we had to be a museum of all the science. We want to attract all the science. We have more science than any other county in the continental United States, and we want to pay attention to that and educate the entire public of Kern County. The higher the per capita education in science, the higher the per capita quality of life, and that's our goal.
That makes sense too. I mean, there's so many things around us, right, that are natural world. I'll ask some of my students sometimes about what's your favorite subject or what's your least favorite subject, and science ends up on both of those lists, which is a strange thing. But I think the students that don't like science don't realize how much is around them and don't realize how interesting it can be because they just haven't been exposed to it. They haven't been taught about it. So this place seems to at least get them started on a path to learn about what's around them, right?
The number one question we get down here is real. Okay, I didn't get my master's degree until 2011. Yeah. Okay, my thesis was real versus contrived. Oh. Real attracts 20% more and more precise observations than contrived.
Right.
So, number one question we get down here, is that real? Is that real? Is that real?
Right.
Real matters. I've got my YouTube channel. I've got my nail bed on the YouTube channel with a 285-pound kid dancing on my chest on the YouTube channel. Do you think, if I've got that nail bed here and I've got the board, do you think it's worth more to the person here for me to have them stand on my chest or watch my YouTube channel?
Right. You know, they want to have it right in front of them.
Real matters, and that's the power of a museum. And we've got the real, and we do a sampling of the real here at the Buena Vista Museum so that everybody gets to have it.
Yeah.
And
then, so do schools get to visit here? I mean, do you take students
absolutely.
in?
Oh, absolutely. We get
Okay.
students here. I used to do field trips with students. You know about that.
Yeah.
I used to take field trips with students. I'd take them to the LA Natural History Museum before we had this.
Right.
Well, what I started doing later on was I'd do the Natural History Museum, and we'd come by here and we'd do the museum here at night.
Yeah.
And so we'd be able to do even a better extension. And some of them liked here better than LA.
Oh, yeah. Well, it's a shorter trip, and you can think about what's going on, and it just seems, again, so real because it's
We
so
don't have
close to where we
Tommies
are.
yet. So we don't have Tommies yet. So.
Well, there's always room to improve. You know, there's always ways that we can make it a little bit better. We're so excited to see all kinds of things that we have going on here. And of course, it's the animal heads that catch your eye when you first come in, but I know there's a lot more to this place as well. So when we come back, we want to learn a little bit more about what actually happens at the museum, what you can see here, what kinds of sciences are discussed, and maybe even a surprise or two about what really exists around us here in Bakersfield and in Kern County that we might not even know about. And I know that Mr. Hanley will be able to show us that. Hey, we're back with a little math in the real world, and we've already been talking to Mr. Hanley about the amazing things that happen at the Buena Vista Museum of Natural History and Science here in Bakersfield. And some people might be wondering, why are we doing science and do the math? But really, that goes back to how you explain science to young people, right? It's the best way to do it, and that's why we have math.
One of my other things, I'm eclectic. I do a lot of stuff.
Okay.
One of the things I do is I'm one of the adjunct teachers at the University of Laverne for elementary school science methods.
Right.
And in order for them to pass the C-set, they have to know certain things. And there's something on the C-set, it kind of frustrates me, but I have to tell my students so that they can pass the C-set so they can become teachers.
Yeah.
And one of them is that in Greek, science means to know.
Okay.
But that's not what scientists do. That's the one that kicks me, is that scientists look into the universe, no matter what your denomination, and they look for patterns in the universe. And what better way to describe patterns than with mathematics? And so the language, that's why I think that a lot of mathematics ought to be taught through the sciences, because that shows you the application for the different formulas that you do.
There's the real world part. Show me, right? Let's look at a couple patterns here, if you don't mind. We were talking about these earlier.
Okay.
And
well, yeah.
Would you mind if we look at these?
Not
we were just talking
at all.
about patterns.
People learn to read by different methodologies, and so every person's got a different set of, whether it's partial word recognition or whether it's whole word recognition, whether it's phonics, that sort of thing. With mathematics, you can learn your multiplication tables many different ways.
Right.
And so you might learn them by rote memorization, but only a portion of the population is effective with rote memorization.
Okay.
When Dad had a stroke and he lost his multiplication tables, I was able to teach him with geometry. He didn't lose his geometry. He can do the triangles for 3, 6, 9, and so forth.
Okay.
Squares. But now there's a Marcy Cook thing where she does stuff with the hundreds table.
Okay.
And
so this is a table of the numbers 1 to 100.
Right.
And these are the multiples of 11. So this is
that's
11.
your bishop.
11,
That's your
22,
bishop going
33,
that
44,
direction.
55. So in terms of chess, this is a wonderful representation of the way that the pieces move, right? So yeah, we have a
Correct.
bishop here, and over here we have 7s and 8s. What's here?
Well, okay. See, 9s would be
and we can do the other one.
bishop on the other side.
Right, you can go this direction. Yeah, the multiples of 9. That's a good point.
And so some kids can see the table better than doing the rote memorization. 8s are the knight. Down 1 over 2, down 1 over 2, down 1 over 2.
Yeah.
And so you get this weird pattern with the 7s, where you start out here 7, 14, 21. And so these are nice diagonals that do serious skips. There's not a piece on the chessboard that matches exactly what 7s do.
But what a wonderful conversation to have with a young person when you say, this matches up with that, this matches up with this piece. What do you think the 7s do? And they might make another association that doesn't have anything to do with chess, but then they've made their own association.
And they
own it.
And
they
they
own
do
it.
it.
Yeah,
Then they do
that's
it.
it.
Well, yeah, the 4s table is really fascinating. You know, I look at it and I think about it like a keyboard.
Yeah?
You got a 4-note spread, but you got 2 together, now you got 3 notes together, now you got 2 notes together, you got 3 notes together, you got 2 notes together, you got 3 notes together, you got 2 notes together, you got 3 notes, and it might be that's the thing, you know, columns for the 5s and the 10s.
Right.
You know.
So we have some materials here, and I know that there's some really neat things you'd like to show us. Maybe a little bit about sound, is that right?
Oh
That we're looking
gosh,
at?
okay, waves.
How about a lot about sound?
Okay, next generation science standards
Okay.
is about unifying concepts, things that apply all the way across the board. And so one of them that I had back in '97, we did technology integrating engineering with kids, and they made rap music videos. And there's a formula for rap. You take the central concept, you repeat it over and over again, and that gives you your cadence, and that gives you your note variation. And so these kids did
So
their
there
own
was
research.
a science to the rap song.
Oh yes, absolutely. There's a pattern.
There's a
to the
pattern, a
to
little
the
bit of
rap.
music. I mean, a little bit of math
Okay,
in there,
and so here was what they discovered. They discovered that the central concept in sound is frequency for pitch, amplitude for volume, frequency for pitch, amplitude for volume. So,
Yeah.
so waves, and so the wave goes on and on. It's just like that endless song, and the wave goes on
That's
and on.
crazy.
And so we have waves in sound, we have waves in light, we have waves in electricity, we have waves in water, we have waves in earthquakes,
Yeah.
seismology. We have waves in just about everything. The anatomy of a wave is basically, so the frequency, the length of the wave is the frequency.
Yeah.
And so the internodal distance, the distance between the cross center line, that's the frequency. But the height and depth of the wave at the antinodes, that's the volume. That's how loud the sound is.
Okay, that
And
makes
so
sense.
frequency for pitch, amplitude for volume. Yeah, I wanted to make a trumpet. I had music as a thing. We were back in there, and of course we started out, we were looking at the elephant, and so I wanted to make a trumpet out of a clear tubing and a funnel.
Yeah.
And I got a Box 7C mouthpiece, and I put it on there, and I wanted to be able to do jazz, But there's too many
Fantastic.
notes in there. That's frustrating. There's too many notes in there. So I went to the band teacher, and he said, you're talking about confined waves in a tube.
Yeah.
And so what you need to do is go to the lowest number, and the first break in the tube is 1 octave. The next break will be 5 notes spread, the next one 3 plus, then the next one less than 3, and so forth, so that you get closer and closer together.
Wow.
And so I ended up being able to get the middle-sized one. I only had 3 notes on the small one, so the middle-sized one.
Wow.
So you can do
That's
jazz.
unbelievable.
when
Even
you get
without
the
a
right-
full-on trumpet, that's unreal. I'm really anxious to hear this one. We want to make sure we leave everyone hanging just a little bit so they'll make sure they return for the last segment. But gosh, what a great way to incorporate science and learning and math all together and make it real for
And
a
the
young
arts.
person.
And the arts.
Yeah, and the arts too, that's right. And maybe even not so young people like this stuff too. Hey, a little math in the real world. We are back at the Buena Vista Museum of Natural Sciences. And boy, we are learning all kinds of stuff. We really appreciate your time here. And the sound got me super interested. So we know that there's one more tool that you have here to make a little more sound. And that just all started from an elephant, right? It all started from, why does an elephant make that sound?
Okay. So that one was the error. That one is a little bit different. See, it's short.
Right.
So this one, the rule of music is that when you have a tube, waves confined in a tube, you take the lowest note, and the next break will be 1 octave away. So the lowest note on this one was 8 notes away is an octave.
Okay.
Okay, and then I go up, it'll be about 5 notes away, less than 5 notes, but more than 3. So I got 4 notes on this one. I can't do jazz on 4 notes. I
Yeah.
can't. So the medium length one was just right, because if I go with the long one, then it's like an elephant's trunk.
Yeah.
It's just too bloody long. There are too many waves. You hear there's no distance between them. So here's the way that works.
Okay.
Okay, in a confined tube, let's say I've got the note A. It's 440 hertz. In a confined tube, the single wavelength is the note A.
Yeah.
Now, if I double that, it becomes 880 hertz, and that is 1 octave away.
Okay.
But when I add the next break, it's another set of waves, but it's 1320 because we've added 440.
Right.
It's not, if it was 1760, then it would be an octave.
And you would see 4 of them, right?
And
'Cause
I
it
would
go
see,
1,
I would
2,
have to
4,
see
but
4 of
instead
them.
we want 1, 2,
If I want to
3.
do an active, I've got to do 4. So that's the
Right.
5, and the balance of the 5 is to the 8 to the next one, and that's when we add the 4th one.
Right.
And so it's the laws of waves. See, okay, laws of waves. It was great. We did the technology integrating engineering where the kids did the rap music video.
Yeah.
Okay.
Okay.
And the formula is, if you take a central concept and you repeat it over and over again, that gives you your cadence and your note variation. And so these kids were really sharp to that. they said frequency for pitch, amplitude for volume,
Right.
frequency for pitch, amplitude, the height of the wave and the length of the wave. Okay, so that's how you make your rap music video. They were better at it than I am. Okay, so I've got this music grinder, see, and it's got short tangs and it's got long tangs.
Okay.
And so if I turn it, it's almost inaudible.
Yeah, you can hear it, but barely. You can
Just
barely
barely.
hear it.
Well, what's missing is the amplitude.
Oh,
Frequency
okay.
for pitch, amplitude for volume.
So we
Frequency-
have some different notes in there, but we just can't hear it because the amplitude's not big enough.
Well, let me use the tabletop here. I'll use the whole tabletop here.
Wow. So the whole table is
Becomes the amplifier. It's
Yeah.
kind of like I put a hex nut inside a balloon.
Yeah.
The faster I spin it, the higher the pitch.
Right.
But it's a small balloon, so if I inflate the balloon bigger, now it's much louder because there's more amplifier.
Right.
It's just like when I do my Jew's harp. Just like when I do my Jew's harp. Okay, I go. Now, I'm changing the pitch with the size of my mouth.
Right.
I'm creating the vibration with the tang, but when I open up my lungs, my alveolar lungs, all the surface area of my alveoli now becomes an amplifier for the sound, and so by opening my lungs,
Wow, it's a lot louder there. So there's so much to learn, and to think it all started with us thinking about how an elephant makes a noise, right?
there you go.
Well, Mr. Hanley, we are so grateful to be here today. We want to make sure we leave you with something because I know we're always adding to the museum. This is our Do the Math tile, and you'll know that we
love it.
visited just because maybe on the floor when you enter, or maybe in the restroom or something like that. But we want to make sure that we leave you with a token of our gratitude for being able to show us some really amazing things, and just a reminder that, doggone, math is everywhere. You know that, but the people who come in the door will also be able to know. There's a lot of math in this place, and not just science.
They'll know we are duly tiled.
That's right. You got it.
Yes, brother.